Good morning. My name is Tom Brennan from Proactive Risk. Thank you for taking the time to join us today. We'll be speaking about continued people, process, and technology. The organization, as you know, is focused on areas to improve software and software security. We realize, of course, that software powers the world, and insecure software threatens the safety, trust, and economic growth. Proactive Risk is involved in both reactive and proactive services. If you're looking at your response capability and you currently have activities in your organization, you've already lost the fight. You're already taking the punch, and it's time for a reactive service. In this conversation today, we're speaking more about the ideas of being proactive with people that are able to go ahead and get into the nitty gritty of the software and be able to associate themselves with the organization and help it fight better and grow. Process is extremely important, especially in software. The monolithic code base is dead. Modern applications are built from code from various sources, and mashups happen all the time. The ability to use components or untrusted components, including open source, are happening at a staggering rate. And being able to get your hands around the elephant takes a team of people to help any organization be successful. Process improvement starts with being able to be measured. Software security plays into the component of being able to be measured around governance, construction, verification, and deployment. Proactive Risk has been involved in projects including the Open SAM project that help organizations in an open source way provide metrics to measure themselves against, as well as organizations that they can be measured to determine based on industry, as well as controls in place to build better software. Today, we're introducing a partnership with CodeDX. Proactive Risk has identified this organization as a tool that will be able to assist organizations, clients that are able to maximize their code coverage, be able to visually look at the ability to identify problematic areas in their code. And with that, I'd like to introduce our friends over at CodeDX. Ken, I'm going to pass you the ball here.
Okay.
And you should have that now.
Great. Yes. Thank you.
And you
All
are
right. Good morning, everyone. Thank you, Tom, for the introduction. My name is Ken Prohl, and I am the CTO for CodeDX, which is a product to help detect quality and security issues in software by correlating the results of multiple tools. The DX in the name stands for diagnosis, a term used in the medical industry, and we help people diagnose problems in their software. A little bit about CodeDX. This is a project that was funded by the Department of Homeland Security Science and Technology Directorate. We had a phase one small business innovation research back in January of 2009, and we had continued funding for phase two and follow-on work through DHS that led to a commercially launched product back in November of 2013. And we've recently spinned off a company off of Applied Visions, which is the parent company. Applied Visions has been around for over 28 years developing custom software for companies like Hallmark, Reuters, and AC Nielsen. We're based in Northport and Clifton Park, New York. Below are some pictures from Northport headquarters, right on the Northport Harbor. And we are very involved with the community. We are organizers, co-organizers for the OWASP Long Island chapter. We're interested in anyone that's looking to join that or be a speaker at that. Please let us know. And we are developers of a lot of freely available community resources. One is CodePulse, which is an OWASP project, and that project helps people visually show code coverage during manual or automated penetration testing, so you can be able to see what parts of the application is not getting tested, as well as being able to compare different tools. So looking at DAS tools and manual pen testing. We also have a website called cweviz.org. That's a freely available website where people can go and learn more about the common weakness enumeration, which is a dictionary of software flaws in software that's developed by MITRE. So you can go there and have a more visual way of interacting and learning about the common weakness enumeration. And we're also participants in the SWAMP, the Software Assurance Marketplace, which is a DHS project that helps helps people develop new tools and run tools in a very large infrastructure for doing this type of analysis. It's a cloud-based resource, and we have some of our solutions that are part of the swamp. You can learn more about that at continuousassurance.org. So we know there's a lot of bad software out there. This past year, there's been plenty of issues that have been coming up, and Heartbleed is one example. There's been many others, and every day there's something new. And it's reported that 90% of security incidents are the result of exploits against defects in software. So it's software that is at the root of a lot of these problems that we're facing today. So, what can we do about that? There's tools that exist to help deploy safer software. One of the most common used tools is static source code analysis tools, and they're pretty mature. They're automated and can be run in a repeatable way. And there's many static analysis tools out there today. The problem is there's no single solution. There's different tools that identify different problems. There was a study by NIST where they ran a whole bunch of tools against various different applications, and they found that there was 84% of the findings were unique, meaning that no other tool found those. And so you really need to use multiple tools in order to improve the coverage. That study was done by NIST, and they continue to do studies frequently and having the same kind of results where a lot of the tools have gaps in their coverage. That study is called the SATE, the Static Analysis Tool Exposition. On the bottom there, NSA has also done various studies, and they have a large test suite called the Juliet test suite that has several million lines of synthetic code and over 60,000 test cases with known vulnerabilities in it. And they ran a bunch of different tools against it, and they found, on average, a tool found only 14% of the known weaknesses. And so there's no tool really stands out as being the uber tool. So you really want to be able to use multiple tools. But using multiple tools isn't so easy. Each of these tools have expressed their findings in different ways. These are two different output files from Fortify and Find Bugs. And so, it's really challenging. This is a quote from Jim Bird, who has a blog on software assurance. He says that working with different tool vendors is confusing and challenging and time-consuming process. The engines work differently, which is good since they catch different types of problems. And that's what we're focusing on with CodeDX, to be able to bring together multiple different tools into a single interface. So having secure software is important. Many people have perimeter defenses in place like firewalls and intrusion detection systems, and they think they're secure. But like the White House, you're not as secure as you may think. An intruder may be able to get in right through the front door, which is what keeps happening with web applications today that are made accessible to outsiders. That allows attackers to bypass perimeter network level defenses. And we really want to have as secure as possible for our applications. And we also want our applications to be of high quality and to be fast. Otherwise, users will get frustrated with program crashes and slow response times. So, and good quality also helps when it comes to security, because both humans and automated tools have a much easier time of finding problems in code that is written well. Heartbleed is an example of that. A lot of the tools just had trouble finding issues, and humans also had a hard time just because of the complexity of the code. So better quality code leads to more secure code. So therefore, it's important for applications to be checked for both quality and security. Focusing just on security without quality is fruitless. These are some examples of the issues that are found by CodeDX. Quality issues like just confusing codes, performance issues, concurrency issues, memory leaks, null pointers, infinite loops, or just redundant indent code. These are things that we want to be able to find and identify in software and fix. And security issues as well. OS Top 10 is a good example of common flaws in web applications today, things like SQL injection, cross-site scripting, cross-site request forgery, and others. So CodeDX brings together multiple different tools in a single interface. And the idea is to, instead of having a single instrument, you want a symphony, taking the best qualities from each tool. These are all the tools that we currently support. The static analysis tools is a mix of commercial and open source tools. I faded out the commercial ones, so this is showing you just the open source or freely available tools that we have within CodeDX. And fading out once again, these are the tools, the 9 tools that we actually bundle within CodeDX. So we automatically will install, configure, update, and run these tools. And that turns out to not be so easy. Many of these tools have their own peculiarities that need to be addressed to get good results, and CodeDX makes that easy for you. These are the supported languages that we have within CodeDX. So for the bundle tools, Java, JavaScript, .NET, C, C++, and Ruby. We'll be adding in support for Python next month. And if you're using commercial tools that support other languages, you can still use those within CodeDX. This is just showing you what languages we support with the bundle tools that we have embedded inside of CodeDX. So at this time, I was going to jump into a demonstration of the product, give you a little bit of a feel for how it works. So CodeDX is a web-based application that is meant to be used among different users, the security team, development team, security analysts, and QA testers as well. This is the projects page. You can see I have one project called My Project. For this demonstration, I'm going to add a new project. This is going to be WebGoat. WebGoat is an application developed by OWASP that has known weaknesses in it. It's really good for training if you haven't looked at it. It's a really good resource to learn about application security problems. And this project, WebGoat, is available on GitHub. And for this example, I'm going to tell CodeDX where this GitHub repository is located. So you can get the data into CodeDX in many different ways. It doesn't have to be in GitHub. You can just give a zip of the source code. In this case, I just gave the URL for WebGoat. I'm going to stick with the standard branch. This is a public repository, so you don't need to enter any credentials. If you did, CodeDX would notify you of the password, username and password that you need to enter, or the SSH credentials. So I just set up the WebGoat. It did a clone of that repository, and now I'm going to do an analysis. So the analysis, so right now it's doing an update from that GitHub repository, and CodeDX is showing me all the different languages that it detected within that repository. I can just click Begin Analysis right now to start running the embedded tools, but instead I'm going to switch to a different tag. So this is looking at a certain tag is this 6.0.1, and I'm also going to add in a WAR file. So one of the tools that we bundle for Java looks at bytecode in addition to the other ones that look at source code. So like I said, having a mix of different tools is really helpful. So I'm going to give it the WAR file and an FPR file. So FPR is the output of the commercial tool Fortify. So you can import those results as well. So whether any of the commercial tools that we support. And I'm going to get rid of some of the tags that I identified in the source for .NET, because I know that WebGoat is primarily a Java application, so we're not going to worry about analyzing that. So I'm going to click Begin Analysis, and now CodeDX is automatically running the appropriate tools based on the languages that it detected, and it's going to be correlating everything together and mapping it to the source code. And this will take a minute or so. In the meantime, I wanted to demonstrate some of the other options within CodeDX. So one is the rules config. So now that CodeDX is running against the WebGoat project, what is it running? Well, it's running all of these bundle tools that we have, and you can select which rules you want to run. So there's over 1,500 rules that are already pre-configured within CodeDX. And we've gone in and disabled a lot of rules that may not be useful for a first-time user. Sometimes you'll get a lot of noise at first. So we've disabled some certain rules, and you can go in and you can disable a whole tool, or you can go in and look at different particular rules that you want to enable or disable. So part of the process of doing analysis is figuring out which rules you want your team to focus on. Another thing I want to show is we have an API that you can use to ingest data into CodeDX. So we have a full REST API, so you can push data in, you can get data out, and we also have plugins for Jenkins. So Jenkins is a continuous integration server, so you can automatically set up CodeDX to run as part of your CI process. So on every commit or every night, you can have CodeDX run, and you can even have it set up to break the build if, for example, if a high severity finding is found. And you also have options to do graphing and trending and things like that. So that's another way of getting the data in if you didn't want to use the more manual approach, which is what I was demonstrating here. So it finished, ran in about a minute, depending on the size of the application, will indicate how long the analysis will take. I'm going to go ahead and look at the results. So now we're looking at 3,383 findings across the 5 tools. Again, one of them was a commercial tool, Fortify. And the idea of this page is to do triage. So, if I'm the security analyst or the development lead, you don't want to go through over 3,000 findings. You want to figure out what's most important, what's the biggest risk, and prioritize these findings. And that's what CodeDX helps analysts do. So the idea is to try and go through and change the status. Maybe you want to mark certain things as false positive or escalate certain things. The filters are very helpful in doing this triage, so we can look at the distribution of the findings. You can sort these by count. So you see Fortify found the most findings, find bugs found the next most. And you can drill in and see the different categories for each of these tools. So for example, if you want to just focus on the security findings, you can do that. You could also look at the CWE, the common weakness enumeration. This is a way of looking at weaknesses across tools using the same language. And all these filters are interactive. So if I were to check off find bugs, you can see this whole page reacts. I'm now looking at 730 findings. You can see that some things grayed out in the CWE. Those are things that were not found by find bugs. You look at the severity. So there was no info severity findings. You see that the low dropped down from before, so you can still get a perspective of how things were before your filters were applied. So let's do a scenario of doing the triage. I'm going to take a look at the code base location. So if I'm the developer, I may want to look at a particular class or package that I worked on. Another example is if maybe there's test code that you want to ignore, or maybe something that's being newly designed. So like there's this new design folder that has 49 findings. I'm going to, in bulk, say I'm going to ignore those. So this allows you to rapidly go through the findings, and doing these bulk operations really make that efficient. So you can see the status has changed now. We have some that are ignored, some that are still in the new categorization, and everything is saved over time, so that if you start marking false positives, and you'll be able to see that stick across analysis runs. I'm going to look at tool overlap. So this is saying which of the findings have overlap between the tools. You can see, which is matching what the studies have found, is that a lot of the findings were just found by one tool, and then we have 12% that were found by 2 tools. Nothing was found by more than 2 tools, and we can drill in and see that which exact tools were found. So this is showing you the findings that were found by 2 tools. You have a little bit more confidence in those results, or at the very least, you have more information because you have multiple tools reporting the same issue. So here now, doing that filter, there's 397 findings, which is still a lot. So one thing you can do is you can use the weakness flow to get a better, sort of a high-level overview of all of the issues that are currently in the filter. So you can see this bar here is indicating a size based on count. So we have more low, we have some high severity and some medium severity. I'm going to move things around in the flow and focus on CWE. So now, from left to right, the most problems we have is this declaration of catch for generics. So some issues with how exceptions are being caught. Maybe it's not something I really want to focus on now. We also have this improper resource shutdown, which is a potential performance problem. I'm going to ignore that for now. But then I see here the SQL injection, and you can follow these flows. You can see that find bugs and Fortify both found them. We have 48 of them. Now SQL injection is a real big problem. It's in the OWASP top 10, and maybe that's something that as an organization we just had training on. I want to I want to really focus on SQL injection as something I want to take a closer look at. So I'm going to go into the CWE filter, look at SQL injection, and now I'm looking at just 48 findings that were SQL injection found by multiple tools. We have the ability to generate reports, so you can generate a CSV report, XML report, or a PDF report. I just generated a PDF report, just showing you basically an overview of everything that you had in your filter selection and details of each of the findings. They're broken down by the type of finding, where it is in the code, and then a description and some snippets of the problem. So that's one way you can go about distributing the information. Another way you may want to do is take a closer look at one of these findings. For example, we'll look at this SQL injection that was found by FindBugs. So up top, it's giving you a description of it, saying that you're dynamically generating SQL, consider using prepared statements. I can quickly jump to the line of code where this problem occurred. You can see here this query variable is doing dynamic SQL generation. This is definitely going to be a problem. At this point, I can assign this to developer. I'm going to assign it to Pete. I'm going to say use prepared statements. And this is updated in real time, so we can actually have a chat back and forth without having to refresh this page. And we can also take a look here. You can see what other findings. So we see that there's the 2 SQL injection findings on this line. There's also a finding about unreleased resources. You may want to just take a look at what else is going on in this file as you're going through these findings. So you have some error handling issues. And these can be drilled in on and get more information. We also have some links up top for the MITRE site and our own CW Viz site. You can learn more about SQL injection, how to go about remediating it. One other thing I wanted to show is the ability to add manual findings. So let's say you're doing a code review and you find something in the code. So you'll be able to import that into CodeDX as well. So now you can have all of your information in one area. So I'm going to input a XSS, cross-site scripting vulnerability. I can map it to a CWE and just type in here, it'll autocomplete. I'm going to say it's in the login file. Again, CodeDX is assisting me in selecting that file, what line number, and we'll just put a description XSS during code review. And now this finding will be added to the rest of them. You can see here the manual entry, and I can filter on that. I'm going to assign that to Pete as well. So now you can see how I've have all unified data in one spot. Pete can come in as a developer and just look at the things that are assigned to him, or he can go into his IDE. So we have support for both Eclipse and Visual Studio. So in this case, I'm looking at Eclipse. I've now showing you all of the findings that have been reported that we just looked at in the web interface. I'm going to filter and just show stuff assigned to me. So I'm logged in as Pete in this case. I can double click on a finding, go to the exact line of code where this problem exists. I can bring in some detailed information similar to what we saw in the web-based interface. Maybe I'm going to mark this as a fix. I put in my fix. I am now using prepared statements. And now that's been entered into CodeDX as well. You can also do an analysis right from the IDE, so I can run a new analysis right from here. So if I perform a fix, I can run the tools again and make sure that the problem is solved before I commit the code. So that's an overview of CodeDX. I kind of went through a lot of stuff, but it really has a good workflow for working both the security teams and the development teams, and now they have different tools to use and collaborate together. And having multiple tool results really provides additional value. And CodeDX makes it really easy to go through the different tool results. At this point, I was going to jump back to the slides. I have a slide on some of our upcoming features. So we're currently working on adding support for Python. We're going to be adding in a new bundle tool for that called Pilot. We're also going to be adding in support for detecting vulnerable third-party components. So a lot of the applications being developed today are being dependent on third-party components like struts and jQuery and things like that. And it's really important for people to analyze with the third-party components as well. So we're going to be adding in support for 2 two open source tools, Dependency Check and Retire.js. Dependency Check is an OWASP project that allows you to detect vulnerable components in .NET and in Java. We're also going to be adding in support for checkmarks. Checkmarks is a commercial static analysis tool. And we also have on our roadmap to add in DAS tools, Dynamic Application Security Testing tools. So instead of just using static analysis tools, we're going to bring in the results of dynamic application security testing tools like Web Inspect and burp and OAuth being able to correlate that with the static analysis results, using hybrid analysis to be able to say, for these static analysis findings, these are the ones that I know are exploitable because my DAS tools are finding them from the outside. And lastly, we're going to be adding support for mapping things to industry standards such as the OWASP Top 10 or PCI DSS. So being able to have a good starting point for your triage, being able to say, well, I only have a limited amount of time. I want to make sure I'm addressing things that are related to the standards that are important to me, like OWASP Top 10 or PCI.
So Ken, we have some questions.
That concludes the. Okay, great.
Yep. So we have some questions here, and for folks that are on the webinar, if you have any additional questions, please put them into the chat function. One of the questions is what are the platforms that CodeDX runs on? What do you support?
Right. So CodeDX is based on Java, so it can be deployed on pretty much any operating system. So we support and test against Windows, Linux, and Mac. So those are all supported, and pretty much any Java servlet container would be able to run and host CodeDX.
Okay. Next question here is, do you support issue tracker integration? And if so, can you point out any of the ones that you work with today?
So issue tracker is not currently supported, but that is something that we are working on. We're going to be adding support for Jira and most likely Bugzilla, so that you'll be able to, right from the CodeDX interface, instead of being able to sign it within CodeDX, being able to also push it to your issue tracker and have that be pushed out to developers that they're currently already using those tools. And so we do have that on our plan.
Okay.
Not currently supported though.
Another question here is, how is CodeDX licensed? Is this done by lines of code of each application or number of processors of the systems that run it? How do you guys price this, and how does it work?
Right. So CodeDX is a very simple pricing model. It's based on number of users. It's not based on lines of code or number of applications. So you purchase a certain user block, and then you'd be able to run it on as many applications and whatever size applications that you like.
Great. And I see here that there's an evaluation code on your slide. So the organizations that want to take a test drive with this, they should reach out to you, Ken, by email or to myself, Tom Brennan, and begin that process. Is that process for a limited time, meaning is it a 30-day sort of evaluation, or how do the evaluations work?
Sure, yeah. So the evaluations are typically a 30-day evaluation. You can use it you run it within your own organization. You can run on as many applications as you like. And, both Tom and myself would be happy to assist you with getting it up and running and answering any questions you may have.
Great. Last question coming in here is, what is the largest application you've scanned with this? Maybe you can put some color into that conversation of types of assessments that you guys have used your tools for.
Sure. So, we're dependent on the tools that we run, but we've done some extensive testing on various size applications. So Wireshark is one example. That's got about 500,000 lines of code. That runs without a problem. We've also run it on that Juliet test suite that I mentioned, and that's I think 2 million lines of code, and that also runs without a problem. The running time can be just a few seconds, like you saw with the WebGoat application today. Something like Juliet would probably take a half hour to 40 minutes or something like that. So as the projects increase, the time will increase. But typically this will be faster than the bundles we have would be faster than a lot of the other tools that you may be using today.
That's fantastic, Ken. Well, thank you for being proactive and helping us point out some areas of technology integration that could help people be more secure. Everyone is obviously very busy these days with defending and fighting the fight, so we're going to close this webinar. If you have any additional questions for Ken, please feel free to reach out to him directly via email that's on your screen, or send me a note if you need to get additional follow-up. I will be following up with people that have joined the webinar and folks that are interested in evaluating CodeDX. And if there's any additional follow-up that's required, please feel free to reach out directly. With that, Ken, I'd like to thank you for taking the time to join us, and we're going to give people about 15 minutes back of their day. Thanks.